Well, hello everyone. Today I decided to try something new. It will probably take several hours to do this. And today I will be doing some very low-level stuff. And specifically, we will try to do DLL injection into all running processes in Windows. And we'll be using Windows 10. Now we will be coding it using WinAPI and C++ using Visual Studio, and in this part it will be just installation and setting up of tools, kind of like basic introduction of concepts and just setting everything up. So this will include some coding, obviously, and I will be coding this using Windows kernel to start all this stuff. So we will be writing a kernel driver. We will also have to write a DLL, obviously, that we will be injecting, and it will be, quite unusual DLL. It has to be, very lean. Yeah, so we will do all that. Now, because we will be coding it using Windows driver, and just for testing purposes, we will be using a virtual machine. And obviously, since this is a driver, we will have to test it on both 64 and 32-bit operating systems. Okay, so now let me show you where I will be testing it. So I have one virtual machine. Technically, you will not be coding it in a virtual machine, but I will do it in a virtual machine, where I have my Visual Studio, well, at this point 2019, installed. So that's where I will be coding everything. Now, I will not be running my actual tests of the driver in this VM. So for that, I created two virtual machines. One is this one. It's a 64-bit operating system, and I can demonstrate it for you right now. So as you can see right here, it's a 64-bit operating system. So we will be running most of our tests here. And obviously the reason you would not be running your tests of your driver in your actual working environment or in your host is because any mistake you make will either severely slow it down, or so you might actually end up with some kind of a blue screen of death, which is a bug check, or the whole thing basically might crash and you might lose all your unsafe data, or even worse, you might totally mess up your operating system. So that is why I strongly recommend testing your driver in a virtual machine. And since Windows comes into flavors, 64-bit will be kind of like a main subject because it's kind of more challenging. But also we will test it on a 32-bit or x86. So this one is a little bit easier, but we will still have to write both and test them. Now I'm using VMware Workstation, but you can technically use a free virtual machine that comes with Windows, or okay, well, that one is not free, but the one that comes from Oracle, which is VirtualBox, I believe. But I will be using VMware because it's set up this way. Okay, so this is kind of like my basic setup regarding virtual machines. So, and the reason I'm using virtual machine here is just to separate from my actual environment, so that you can have a kind of like a cleaner version of what I've been doing. So now let me give you some basic requirements that you would want to install. Now, as you can see on my development operating system, I already have some tools installed. We don't need all of them, so let me quickly show you what you will need to follow up with me here. Now, first of all, let's go back to our development machine, and as you can see, Visual Studio 2019, I'm using Community Edition. So you need to install it, and also if you go to Start, if it's already installed, and go into Visual Studio Installer, let me close this one, the installer will come up, and you will have your version here. Click Modify, and we will need to modify some settings here. Now, before you install everything, make sure to install desktop development with C++, so you need that stuff. And also, before you do anything, you need to install Windows Driver Kit. It has to be done separately, unfortunately, so make sure to download it from the Microsoft website. I don't know which specific version will be available here, but make sure to download it and install it first. And then when you install it, when you again start Visual Studio Installer, click to individual components, and if you scroll all the way down right here, you should have Windows Driver Kit checked. Also make sure that you have the latest version of Windows 10 SDK installed, whatever that is, available. And as I said earlier, you will need, kind of like general, you can just select here desktop development with C++, because that's how we will write most of our components. And also, now I have, there's like a large list here, but if you search for Spectre, kind of like TRE at the end. So what you will need to install the latest, for the latest version for Microsoft Visual C, and I also install it for MFC just in case. And then when you do all that, make sure to install it. It might download like a couple gigabytes of stuff, so all of that is important. And this is concerning Visual Studio. Now again, since we will be coding a Windows driver, you need Windows WDK. Okay, now then if we go into our test virtual machine, we will need to do the following for both 64 and also x86. Now I already installed most of it on the x86, so I won't show it here, but I'll show it quickly for x64. So this is a brand new installation of Windows 10, and I think, let me see which version it is. It's Windows 10 Pro. Well, I'm using N version, which is a little bit leaner, but Windows 10 Pro, so that we have all the features. And let's go one thing at a time. So first thing first, we will need to install a process hacker. And I apologize, Microsoft just can't let you use things without showing this stuff. So let me pause it and see, wait until it's done. Okay, so I apologize for this. I should have installed Chrome here, but I'll do it later. Okay, so the first thing you do process hacker. You search process hacker. Make sure to download it from this URL. Let me see if I can enlarge it for you. From this URL or from their GitHub. Okay, so you go into process hacker. I personally prefer downloading binaries without setup. So let's show in folder. And I'm going to go one thing at a time. Now, since we are on 64 operating system, that's what we need. Now I'm going to do quick and dirty, so I'm not going to be going into any specific installation here. All we need is to get rid of this thing. Okay, so I'm going to put a shortcut here. Make sure that it runs. Usually make it a little bit slimmer on the side here to make sure that it doesn't obscure everything. But basically, this is a process hacker. I like it way better than this thing. So we will use it a lot to see, how our DLL is doing. So that is that. Then make sure to download DebugView and download it from the Microsoft website. And DebugView, it's a sysinternal tool by Mark Rusinovich. Okay, let's download that. And again, let's see, yeah, we just need this one. And let's run it as administrator. Oops, if I remember how my account is. Okay, so now the DebugView tool would basically let us capture all the output from the kernel. Unfortunately, some driver keeps spamming us with all this information, so we need to put a filter. It's a storm ini, whatever that is. And let's make sure it sticks. So again, we have to run it as administrator. Yes. And here we go. This is how we will be capturing debugging output from our driver. And also from PsInternals, we need another tool called WinObj. Kind of strange name. Also make sure you get it from Microsoft. It will show us some kernel objects, so let's download that. And again, we just need this one. Let me run it. And it's running all right. Okay, so then we will need another tool called PEInternals. Now this is not a Microsoft tool. Let me see if I can find it. And what I usually do, I usually go to the website of the manufacturer. It's this one here. Anyway, that's the website right there. And we need PEInternals. And we need to download it. Now this little tool will help us look at the PE contents of the PE file contents, which is very helpful. And let's see, we need 64-bit. And because it's a third-party tool, it's not signed, so I have to do this. Let's make sure it runs. So what we can do, if we can, drag the file into it, we can actually see, what's inside the PE file, which is very, very helpful. Okay, then we need my own tools, a couple of them. So for that, we will go to my website, dennisbabkin.com, and which you can do that. You go away. Seriously, Microsoft. Go to Utilities, and we will need WERSetup, Windows Error Reporting Setup. So let's download that. Download it. And let me get to it. Again, I'm going to put it over here. Okay, so let's run it as administrator again. Now what this tool does, you can click on the information here, but basically it's setting up Windows Error Reporting Service to save any crashes into a specified location. Now it will be saving dump files into the folder that we provide, and let's do that. Now the reason we would set it up is that we will be injecting our DLL into all processes, and if it crashes, it would be nice to catch those crashes into this folder and actually analyze it later, because that will be very helpful. Okay, so we will create full dump and we will limit it to 10, right? And make sure to save it. Let's see. Make sure that crash dumps is created. Again, any crash dumps that will be happening in this operating system will be saved in this folder, which will be easy for us to analyze. And then we can tell, okay, this was caused by our injection, or if it was caused by something else. Okay, so that's that. Now then, if we go back into utilities, and what we need is a tool called WinAPI Search. So let me download that. Oops, what happened? Downloads. Where's my downloads? You're kidding me. Okay, Microsoft. Okay, so I will extract both of them into, well, let's say, my documents. And I'm going to create a shortcut for one of them. Let's just clean this up. Okay, now this little tool will help us see the contents of a file, and not just the contents, but it's kind of like, well, what dependency walker used to do, but also more. For instance, it can show us all the imports and exports. For instance, if you want to see like what's imported, you can just do this and it gives you all the APIs, or if you want to see all the modules that are imported, you can also do this. So it's kind of nice and easy way of studying the contents of the PE file. So we'll be using that. And lastly, again, if you go back to my website to utilities, we need driver loader and unloader tool. Okay, it's this, has this icon. It's downloaded. And if we go here, in this case we need just a 64-bit version because we are on a 64-bit OS. And this little tool will help us set up our operating system here. So, and also it will help us start our driver and also stop it. So this is kind of handy. Now, before we do anything, we actually need to ensure that we can run our driver. Now, the way Windows 10 is set up, and I think it was like this since Windows 7, is that you need to have your driver signed by Microsoft to be able to actually run it. Since we don't have our driver signed, we need to put our operating system into a test signing mode, because otherwise you will not be able to start any drivers. Now to do that, we will use our driver loader unloader tool. Now for that we need to run it as administrator. And then when it's running, go to Edit and click Test Signing Kernel Drivers. Now don't do this on the operating system that you're using for something, because obviously it makes it less secure, and also you might experience some issues with bootloader or whatever other software and especially drivers you have installed. So again, do it only in the VM. Make sure to click yes. And now what we need to do is to restart it. Now again, test signing is definitely mandatory for testing, because again, you don't want to just, even if you can sign your driver, you don't want to sign it every time. And this little tool can do it for you. Now, if you're curious to know how you can do it without the tool, there is a documentation. If you go to the blog post that I created about this whole project, you will have a specific link that will show you how you can do it manually. I personally like to use this tool because it's just one button click away and it's all done. So now when you run driver loader unloader, it will show right here that we are in a test signing mode and we are on a 64-bit OS. Additionally, if you see right here in the corner, I'm not sure if you can see it, Windows is displaying this little warning which says it's a test mode, which means that you can now run unsigned drivers and install them. Okay, well, one last thing we need to do is to actually create a snapshot. Now, the reason you would create a snapshot is because you might have a lot of issues running your driver. For instance, you might, install it and it will totally mess up your operating system, so it wouldn't even boot. In that case, it would be prudent to set up a snapshot in your VM, and well, after that, you should be able to restore your system back to what it used to be. So since I'm on in VMware, let me do it real quick. So go here, take snapshot, and I usually just create a snapshot with the date when I did that. And here you go. So the snapshot is done. Okay, well, now that the setup is done, so we have our both VMs set up. Again, make sure to install all of these tools in both VMs, in 64-bit and also in a 32-bit one, because we'll be testing on both. And for now, let me explain a little bit of terminology. So let's see if I can use this thing to actually do some drawing. Now I have to warn you ahead of time that I'm not good at drawing on the computer, so I'll try to do my best. So, well, first of all, let me explain what the concept of a DLL is. Now, I'm not going to go into all nitty-gritty, just kind of like basic overview. So if we take, let's say, computer RAM, just going to draw it as this kind of like long bar. So let's say, so this would be physical memory. And I apologize for my poor penmanship here. So this is the address 0. Just write it a little bit better. So the address 0. And over here, that's whatever the max address is. Now, this is physical memory. So in other words, this is your RAM that you have in your computer. And this physical memory is different for everyone. So in your case, if you have like 4 gigabytes, this would be 4 gigabytes. Okay? So, and then if we take, let's say, 2 processes, I'm going to call it proc 1. And let's say you have a second process, just to make sure, just to kind of like illustrate, just to illustrate that they are of a different size. I'm going to draw them slightly larger. And proc 2. Now, what are these things? Well, let me show you. So if you start a process hacker, pretty much all of these things, right? These would be individual processes that are running on the system, right? So there's more than 2, obviously. There's a whole bunch of them. I'm just simplifying here for the purpose of this illustration. Now, each of these processes is running in its own virtual memory, right? And this one also has its own virtual address space. Now, what's the point? Well, the point, kind of like in a nutshell, is that a virtual memory is a way to separate memory from one process in another process. So in other words, this process has no idea about the memory contents of this process and vice versa. And this is a security barrier, and it's also a stability barrier for the operating system. And the basic idea is that virtual memory in every process is mapped to the physical memory. The CPU does it pretty robustly and pretty quickly, and this is how it all works. Now, if we look at the mapping of the file itself, like on the top, this thing here would be its own PE header, or not header, PE file, right? And this process too, well, let's say it has a little bit larger PE file and PE2, right? Let me just draw it with a different color. Well, let's say it just happens to be that PE1 is mapped here in virtual memory, right? So let's just see if I can draw it. So P1, man, I'm really bad at that, so I apologize. So P1 goes here, and P2 being slightly larger, let's just say that it happens to go here, right? They're obviously different because, you know, this memory is different than this one, so they're mapped differently into different physical memory, into addresses in the physical memory. But if we, let's say, change color and say that a DLL that is mapped here, let's say kernel 32 DLL is mapped into each process, also kernel 32 DLL is mapped here. Now, what is DLL? Well, DLL is basically its own PE file that has like certain functions that are grouped by certain meaning or certain specifics. And it's kind of like vague and not very well defined in Windows because of the really long legacy. But certain functions with certain specifics go into certain DLL. So, and that's what happens here. So kernel DLL is one of the system DLLs. I just took it, you know, just for the heck of it, but there is more. If you look at, again, if we start Process Hacker and go into any process and look into modules, oops, let me take something that I can actually open like Explorer and go into modules. Now this huge list, you see like all of these things, we sorted by name. All of these are DLLs. You see like kernel 32, it's loaded, but also there's a whole bunch of them that are loaded into each and every process. So if we go back, so our DLL, what makes it interesting is that it's obviously also mapped somewhere in physical memory. So let's just say here, well, because this is the same file, the same contents, the contents of DLL are mapped into the same location in physical memory. So DLL is kind of like a shared area of memory that is shared among all the running processes. This is kind of like an optimization because, as you can imagine, since, you know, every process has a lot of code that is loaded into it, if we share certain code which is, you know, the same for every process, we can save on physical memory. Because, you know, if we run 20 processes, they all will be mapped into the same location in physical memory, so we don't waste a lot of it. So this is kind of like a basic concept of a DLL. And in kernel terminology, DLL is also called a section. I'm going to put it in quotes because for some reason they use it in kernel only. And in Win32, they call it file mapping, I think, or memory mapping. But the terminology is section, which I will be using also when I'm coding this project. And the relationship is basically every DLL is a section. And just to understand what the section is just a section or a part of a virtual memory that is shared among processes. That's all it is. It doesn't have to be DLL. It can be, you know, just a little, you know, area of memory that is shared. So, and that's what section is. So this is kind of like basic overview of this concept of DLLs and what sections are. And this is what we will be working with. And finally, going back to our task at hand, which is DLL injection into all processes. So what we will be doing, if we run our process hacker. Let me run it as an admin so that we can actually see into, into every process. Well, let's just take any process. I'm just picking any random one. So again, if we go into properties, then modules, you see all this huge list of modules. So our goal is to put our DLL, which we'll create and call somehow, into every single process. So whatever we open up, when we go into modules, it has to be loaded into it. Now, how do we do this? Well, we can't really do this from user mode. We can into some processes, but we can't do into all of them. But what we can do, we can actually use a driver to install, to inject that DLL into every single process. For that, there is a specific API which is called PsSetLoadImageNotifyRoutine that we will be using to actually inject our DLL. Now, as you can see, it's using, if you look and read through the documentation, make sure to get it from Microsoft website. This API sets a callback, and this is the callback itself, that will be called every time a module is mapped. Now again, a module is, if we go into properties, one of these things. So when every single time one of these modules is mapped into any process, user mode process, our callback, or this function, will be invoked. Now the problem for us is that because we have so many DLLs that will be called, we need to actually catch the moment when only the first time this thing happens. Now, if you look into the way Windows works and into the way the DLLs are mapped, the first DLL that is mapped is not actually kernel. There's another one. Let me see if I can draw it with this one. There is another DLL that is mapped before it, which is NT DLL, right, into every process. It's not part of the PE. Let me just adjust it real quick. P would be from here. So this NT DLL is the first DLL that is mapped pretty much into any user mode process. Now, unfortunately, we can't do anything at that point because, at that point, nothing else is mapped. All we have is just our PE, which is not going to be enough. But then if we actually go into kernel DLL, into kernel DLL, kernel 32 DLL is the second DLL that is mapped into every non-native process. Now, if we go back into our process hacker and open literally just like any process, you will see, make sure to sort it by name, you will see that NT-DLL is loaded, is NT-layer DLL. This is basically a DLL that is marshalling all the system APIs from user mode into kernel. And the interesting thing, let me just find it, open file location, come on. Open file location, doesn't want to do it. Oh, come on. Let me just find it real quick. So it's C Windows System 32 NT-DLL. Now if we open it in WinAPI Search and search for let's just do all in modules only, you will see that it's only exporting from NT-DLL. It doesn't import anything, it's just using exports. It doesn't import anything, which is very unusual because if you take pretty much, any other DLL, like let me just put some random one and do the same thing, modules only, you will see that there's a lot of modules that are imported and also, delay loads and a lot of stuff that's imported into it. But NT-DLL is that special library that doesn't import anything, okay? Well, if you also look, there is also kernel 32 DLL. Let me see if I can, oh, come on, process hacker, they broke something. But anyway, kernel 32 DLL is the second DLL that is actually injected into every process. So if that's the first one, that's the second one. Again, first one, second one. So, and that's how we can track when the process is starting and when we need to inject our DLL. So if from our callback we can catch the moment when NT-DLL is injected, we can inject our DLL before kernel 32 DLL, and then this way we can do it, you know, we can ensure that our process, our DLL is mapped into every single process. Okay guys, so this is a theory. I understand and this is somewhat confusing. I will show it better in code because, you know, you'll be able to see, you know, what I'm doing. And yeah, so this is how we will be injecting our DLL into all running processes on the system. So for now, I'm going to stop this, and in the next module, in part 2, we will begin setting up our initial projects in C++ and actually try to do some coding. So thank you very much for watching, and I'll see you in the next installment.